camera subscribers. Let's have another crack at the Vektor 06C.02 from Moldova. Moldovan SSR actually. So Soviet era. So the issue we've had is basically the sync. It's supposed to have really good graphic capabilities for the time. But the issue we've had is the machine's working and we can almost get a video signal out of it, but there's something wrong with the sync. So thanks to PCBWay, they've been an awesome sponsor of the channel and continue to be, so I'm eternally grateful for them because it's really helped us out. So what I've got here is two PCBs that arrived today. So the first one is something I've been meaning to do for a while. It's a DIN to VGA kind of patch board. So a lot of, well, most Soviet and post-Soviet computers, you know, like the ZX Spectrum clones, come with, I think that's the, no, that's RGB. So I come with DIN sockets for the video output. And it'll be like 5-pin or 7-pin, depending on whether they include audio or not. And the pin out is always different. It's always different. I have actually made a cable for this, a DIN to VGA, but I don't know where I've put it. Anyway, so I thought we'll use this one. So again, the idea is that you've got your DIN coming out. So I've made it 7-pin, so you can use either 7 or 5-pin. And then you've got your VGA here, and then it's just a matter of kind of, if you don't know what the pin out is just kind of patching it until you get the correct signal. Then you can, you know, spend the time, half hour to actually make up a proper DIN to VGA cable or whatever. So we'll make this one up and use it on here, and we'll check what the video signal looks like at the moment. Then we'll try my little video mod board. So this is based on the difference in two schematics I've got. So I've got the schematic for my machine, and then there is a schematic that shows some modifications which I believe should improve the sync for modern displays. So the way the sync works at the moment is fine for Soviet era TVs, but for modern LCD and capture devices and stuff, it's not good enough. So I'm hoping that this board should fix it. So what I've done is as per my previous video, I've basically redrawn the current schematic and redrawn what I think is the modified schematic, both in KiCad, and then implemented the difference on this board here. So I think there'll be a couple of cuts on the board required, and obviously some patch leads going everywhere. But I think that would be easier for me to do than try to actually implement the changes on the board itself. So that's the idea. So I'm hoping, let's see. So we'll make this up first, see what the current video output looks like again, and then we'll try that out. All right, so the patch board is made up. Small issue with the VGA connector. I think there were two different footprints, or two slightly different footprints in KiCad, and I chose the one, well, with the rows like that. But the VGA connectors I've got, the rows are slightly further apart than what I had, so I had to bend that row in, and kind of force it in. So something to bear in mind. So I'm gonna have to buy some new VGA connectors. Well, I'm gonna have to keep both in stock, I guess, both this one and the thinner together rows. So, but anyway, ready to go. So next is to make up a DIN cable. So 7-pin DIN that'll plug in. Which one's pin 1? So pin 1's there. So we'll plug in like that. So that will connect to DIN on the Vektor, and then I've just got my little patch leads there. I already know the pin out, so it's not a problem. And then VGA off to the well, the HDMI video capture thing. Getting there. Right, and after a little bit of effort, here's the little DIN connector. Nothing special, nothing as fancy like I used to do, but just something quick and dirty. So that'll plug in like that. Plug that into the Vektor, and then get my Arduino era patch cables. All right, a little bit long, but they will do the job. And let me get, all right, so I'll get those out and I'll get the pin out, and then we'll be good to give it a test. Right, we're all set up, so I've got it connected up, and just using the GBS control with whatever firmware is in it. What the? Let me start recording. So there was almost a stable image there. Okay. Well, there was a stable image. Let me just move it. Very dodgy. Although we keep losing sync, I guess. So I'm just changing the output resolution settings. See, that's a stable image. Downscale. I know what downscale does. Pass through. No, nothing. All right. Let's just go to 1280 by 720. Right. Oh my God. Is that working? I've never had a stable, even using it's even using the GBS control. It's never been exactly stable. Of course, the thing now is I need to figure out how to actually load, because it doesn't actually have an OS as far as I know. My understanding is that it's basically got you need to bootstrap BASIC from tape, for example. VVod, block, Spros. So I guess that's Spros, that's the reset button, maybe, but you probably have to press something else, don't you? So that's almost stable. Oh, okay. Let's try different resolutions. 1280 by 960. It's not fully stable, but it's been a lot more stable than I've had it for a long time. And then 480, 561, which is technically what it should be, I guess. Although you can't see the top of the screen. 1920 by 1080. So that's a lot more stable than I've had it for a long time. Just change the sync. Alright, okay, so that's gone. It's lost the sync. Let's go back to what it was. So maybe this thing needs to tune. See, this is what I've had for a long time now. Okay, I guess it's kind of lost the sync, has it? And it just takes a while. Oh, see, I don't know much about GBS control, but does it just take a while and then finally it locks in? Is that right? Anyway, still too unstable. I just want to be able to run this. I don't want to have to use anything fancy. So that's what we've got at the moment. Let's build this. Let's stop that. Let's build this and see what happens. If anything, hopefully, maybe we get a bit of a brighter image as well. That would be good. I've made it. Not the best job. As you can see, my 220 ohm resistors are rather large. I don't know why I ordered them so big. But anyway, I've got to make do with what I can. 1K trim pot rather than 10K. I didn't have any 10K trim pots. And the schematic didn't specify what size. So we'll give that a try. So I guess we've got we'll have two connections for power, 5 volts and ground. We've got sync in and then sync out, so hopefully a good sync now. and then we've got RGB in and RGB out there. So three wires, two wires, DuPont type wires. And now I just got to figure out where on the board to make the connections and make the cuts. I need to go grab the schematic and compare. I don't think it's too difficult. I don't think it's too difficult, so it's just a matter up here, one of the resistors, I think we need to cut the trace, and these are the chips here, I think, where we get the sync, and then obviously this is the RGB connection there. Yeah, okay. Right, good morning, new day. So it looks like it should be pretty easy to install my mod. Well, it's not my mod, but whatever. So at the moment we've got up here, we've got RGB and Luma. So we've got the composite signal being generated up here, composite video, I think. And then we've got the composite sync down here connecting up, and then so we've got composite video, and we've got like a buffer there, I guess. And so this is what we're using for sync at the moment. So one of the things we need to do is we need to cut that, so that's no longer impacting the composite sync here. So that's R65, so we need to make that cut on R65. Now for RGB, so at the moment we've got RGB coming out from this RAM here by some, I guess, voltage dividers or something to get the levels, relative levels correct or whatever. And then we've got RGB on the output. So we need to basically cut these here as well. And that's where we install, that's where we connect to our board. So that's where we've got transistors, so separate buffer on each RGB line. So R68, 69 and 70. 68 to R70. So we just need to make sure that the connection from R68, 69, 70 to the DIN is cut, and we splice in there. Now I think the final thing we need to do is down here. So we need to, basically we need to isolate this. So we isolate that, and then we connect up to here to the inverted horizontal sync, and we pass that through another transistor, and then that goes out via a new variable resistor, which I've got a 1K trim pot, so which then connects up to there. So some bits and pieces in here and then connect up to that. So that should be pretty simple as well. So we've got we'll be picking up, so pin 6 of D89, we'll be picking up the output there, going to our board, and then the output from the trim pot will be going to the common connection between R71, 72 and 73. And also we need to add power, 5 volts and ground, and that should basically be it. Now, the other interesting thing is because I'm using a VGA output, VGA has horizontal sync and vertical sync. So at the moment, I'm just using composite sync, which I think goes to the horizontal sync. But if I wanted to use a separate V.SYNC, at the moment, because we've got a 7-pin DIN, we've got like a control 12 volts here, I guess, for SCART switching or something, whatever they did back then. Or no, actually, this would be to power an RF modulator, I guess. So this would power an RF modulator, so you could, connect it into your antenna on your Sovietsky TV, Electronica TV. So we could reuse that pin 7 for, so say we've got composite sync there, composite slash, well, we could actually, so we've got horizontal sync there and we've got vertical sync there, so we could actually have separate horizontal and vertical syncs. But let's just see what happens with the composite sync with these changes. Might be good enough. Let's see. G'day. Let's try and get this done. I've been a bit slow with this, just, I don't know, pessimistic. I'm pessimistic that it's going to work. I've made some mistake, but let's try. So I've done some photos and labelled them up of the various points. So where I need my mod board to kind of splice into. So I've got sync out there. So for example here I need to basically cut there and there, but actually what I can see is it's actually been cut before. Where is it? There, you can see it's actually been cut before and has been patched. So I need to remove that, cut there, and then patch that over to there, and that's a transistor there. I guess I can try and show you on the schematic what that is. So that one there that I'm trying to do, cut there, that's making this cut here. So this is the composite video. That's what all these resistors are here. So that's all the composite video that was connecting up to this R65, which is on the end here. So we're cutting that. And then on the other end here we've got R49, which is this one here going to ground. So that was coming into there. And then that's VT1, the transistor on the side. So that's what this is for. Okay, makes sense. Now this is the RGB. So we've got I've got my sync out there. So these ones here are these ones over here. So we're not too worried about them in this one. So here we've got R68 red, R71 red. So they are these ones here. So R68. So we've got the red signal coming in here. So we've got R68 and we've got R71 connected there. So we want to pick up the signal basically. So red out, or no, red in is basically we're picking up, well, where's the other picture? The back side of it. I just had it. Oh, here it is. This probably shows it a bit better. This is the same side but the other side. So you can see we've got R68, which is connected through to R71. So we've got R68, R71 connected there. So that's where we're picking up our red input signal. And then on our little board we've got this extra buffer transistor. One of these ones. So basically we're taking that red signal in, sticking it through this buffer transistor, and then red signal out. So the red signal out basically goes to the DIN connector. So we're picking up the red signal in here, and then we're outputting it straight to the DIN. So what I could probably do actually is actually wire the R out straight to the VGA connector. Anyway, we'll see. So that's what this one is. So this is all on my GitHub, by the way. So yeah, so that's what that is there. Now we've got the sync out. Those two go together. Now, so this one here. So I need to cut. So we've got D90. So D90 is this and whatever, or I don't know. So we've got the horizontal sync coming in, and then we've got basically yeah, we've got the sync going out to the RGB there. That's where it was going out to. So you can see that here actually. So you can see that pins 4 and 5, pins 4 and 5 there are bridged, and then 9 and 10 are bridged up there. So we've got the output coming out on 6 and 8. So pin 6 there, pin 8 there. So we basically want to cut those. Why aren't they joined? I'm not sure. Anyway, and then yeah, we basically just want to isolate this. We don't want this output anymore. And then we're going to pick up the inverted horizontal sync. So that'll be our sync in for our little board. So we're going to pick up that from D89. So from D89, so that'll be our sync in. So we're going to pick it up from there. And then our sync out as we go out via this transistor and trim pot. That'll be our sync out there. So that's where we pick up this sync out. Up there. So basically there should be a couple of cuts and sorry, zoom out. A couple of cuts and couple of patches. We'll see what happens. So I'm going to say a bit low energy because, to be honest, I don't think it's going to make any difference. I'm just pessimistic about it. So that's why I've been kind of dragging on. I've got a load of other things, of videos I could have done. But I know my long-time subscribers are more interested in seeing this than seeing something else. So I want to get this done. So I'll start and let's see. All right, slowly. So I've got the sync out and sync in now wired up. And I've made the cuts, so now it's, well, I've got to add power as well, but now it's basically just the RGB in, RGB out that I need to pick up. So I was thinking, yeah, basically, because we've got a whole bunch of wires here obviously to connect them up, so pick the RGB in up here and then actually I'll need to cut it actually, won't I? Yeah, I'll need to make more cuts because this is going to go over to the DIN. Yep, there is a direct connection over to the DIN. As I say, I'm hoping this works, but I'm just not confident. I'm just not confident. So this is the RGB output here, and that's the resistors over here. So if we have a look, say red, so R68, let's just untangle the probes. Gotta go start cooking dinner on the barbecue in a minute. So R68, everything's tangled up today. Okay, so R68 is that one there. So that's R68, which then connects down to R71, which is that one there. And then I think R71, this track here, goes over to, yeah, whichever DIN pin. So I think if I get RGB, so if I get red input signal there, and then I'm going to have to make a cut somewhere here. Well, I can make a cut here basically, and then use the wire as the RGB out, if that makes sense. So I probably could have marked it up on here. Red. Yeah, anyway, that's the plan. And then it's basically done. We'll be able to test it. So that's why, like I said, that's why I did the board, is just to try and simplify. Once you've made the board, then it's just a matter of making cuts and wires, rather than having to try and get the transistor on the board and the resistors on the board as well. And anyway, whatever. Okay, getting there. All right. It is done. Yeah, for power I've just hooked across one of the decoupling caps. So we've got RGB out here going to the DIN, I think, we've got RGB in, so the signal being generated, and we've got the horizontal, inverted horizontal sync, and then something anyway. So I'll just put that there so I don't short anything. I'll try not to short anything. So I've still got my, whoops, my little VGA patch board connected up to the GBS control, and then I've got it connected up to my Mac, my old Mac Mini server. Let's open up QuickTime. So I've got HDMI capture, HDMI to USB. So new movie recording. Okay. Plug the power in. And power on, I guess. Okay, it does look like there is a signal. No, it doesn't look any better. Sorry, I should be recording this, shouldn't I? This is what I was getting before. Okay, let's just fiddle with the current output. 1920 by 1080, 49.78, so basically 50 hertz. Resolutions. We go down to pass through. What does pass through do? No. All right, let's not do pass through then. Let's do 485.76. It's a brighter image, that's for sure. It's a brighter image. So I wonder. Yeah, okay. Something's getting very hot on this. Okay. Let's just disconnect that. Oh, far out. Okay. Something's going very wrong with this. Power off. Wow, okay. I don't think I shorted anything out. It's still generating an image, wasn't it? But this was getting very hot. Which transistor? I should get my thermal imager. Something's getting very hot, like it was getting shorted. I'm pretty sure none of that's shorted. All right, let me get my thermal imager. I'm gonna give it one more go, but I've got my thermal imager here just to see what's getting hot. So I can go back to the drawing board. Let's start recording the video output. Power on. Whoa, geez, yeah, you can see it already. Hang on, let me start recording. Record video, yes. Yikes. Okay, I had a thought maybe it was going to be that one. Let's power this off. Let's just stop recording. So it's going to be fucking up the sync, that's for sure. Let's stop recording. Okay, power off. All right. Yeah, I think, yeah, VT6. I think it's to do with the sync, because I tried to go by the schematic, but I didn't think the transistor was around the right way. I'm not used to that working using the collector like that. I think that's VT6. Oh no, that's VT3. What's VT6? Oh, VT6 is the, oh, okay. VT6 is the blue. Oh, okay. Is the blue transistor. Alright, maybe there is something I can fix about that, but I don't think that's going to fix the sink though, is it? Alright, let me have a quick look at that. I've fixed the short. I had one of the colours kind of shorted to ground or something. Anyway, let me start recording. So, yeah, definitely the brightness is improved. I've got the vertical sync. So VGA's got additionally vertical sync. So horizontal sync / composite sync you can normally use, but if you've got a separate vertical sync, which we actually do in this case, we've got the vertical sync off D83. So pin 9 is positive going, I guess, and pin 8 is actually used. So pin 9 is not actually used. Pin 8, I guess, is the negative, and it comes down here, and that's kind of how we get our composite sync with our horizontal sync, something like that. Anyway, so that's D89 here. It's a nice ceramic chip. So let's try pin 9. Just hook it up. So we're just connecting V.SYNC to pin 9 very roughly. No, okay, no improvement. Let's go to the negative going. Magic. It's okay, that could be because I've got a very I'm holding it via, it's dark, but it's a rock solid image. So maybe I need to hook up vertical sync as well. Well, I don't know how to improve the... Okay. All right. Let's stop that. So, let's power off. Okay. So maybe a little redesign. I was thinking of redesigning the board as well, just to make it easier to mount. So for example, for the RGB in, I've got it hooked up to the pins of the resistors. What about if I just take the resistors out, put them on the board here, then I'm left with holes here that I can plug into. So I'm thinking maybe moving those to the PCB. And we do have 12 volts on the 7-pin DIN for the RGB, so we don't need the 12 volts. So I could disconnect that and use that as the vertical sync pin. So we basically have VGA output. But then, yeah, it's just the brightness. Need to sort of think about the brightness. What do you think? That sounds like a way forward. The image was rock solid. That's the best image I've had for a while. All right, let me know what you guys think. Thanks for sticking around this long, persevering. I really do appreciate everyone's help, input, advice, constructive feedback. So yeah, let me know what you think. Okay, time for 10 o'clock on a Sunday. I'm going to go quickly edit this and then have a break. Bye for now.